Okay, so what you're gonna do is you're gonna go to stat, edit,
How do I, what?
We're not there.
stat, edit.
Calculus.
Okay, now what?
I'll wait until everybody's there
Med.
and not talking.
Dude, Carson, are you serious?
Alex. And then I'm gonna type in my values. So 3, enter, 4, 5, 6, 8, 10. From there, I'm gonna go back to my stat button. So stat, calc. Then I'm gonna enter one var stats, means one variable statistics. I'm only dealing with one variable right now.
List.
Then so calc is when you hit the right button. So stat, then the right arrow, then enter. Keep list 1, hit calculate.
How'd you get an L there?
It was already there for me.
I was just
So L1.
Yes. So x bar is 6. That's my mean.
What's frequency?
Frequency list, leave it blank.
So calculate.
Yes.
When I put in list 1, it puts in list 1.
It is always going to give you x bar. It's always going to say x bar. So if I'm talking about a population, then it is up to you when you're recording it to say mu equals 6. So it's always going to assume it's a sample, but it's up to you to change the notation if you need to do so. Everyone hear me when I said that?
Yeah.
The calculator is always going to say x bar. But you, using your statistical knowledge, have to know whether it's a sample or a mean, or a population. Almost always it's a sample. But in some cases it's population. So I think on this example, it's sample. But we'll get to one later where it's talking about population. Now, you don't need this, and you don't need this. We will need both of these numbers when we talk about it tomorrow, or next class. Those are my standard deviations. Then if you keep scrolling down, it's going to give you the numbers that you'll need to make a box plot, which we'll do later this chapter. Okay? So from there, something that I do want to show you just kind of why this is the average is we're going to take each individual value and see how far they deviate from the mean. So if I were to calculate how far each point was away from the mean, that -3 means that value is 3 below the mean, 2 below the mean, 1 below the mean, 2 above, 4 above, exactly the mean. If I were to add these, they would add up to what? 0. Will this always be true?
Yes.
Yes. The answer is yes. So when you're averaging something, if you took the sum of the residuals, or the sum of the deviations, you can call it deviations, we'll call it residuals later on, is always 0, because the mean is your balancing point. Just how far away you are from the mean. If I have a negative residual, then that means that it's below the mean. If I have a positive one, that means that it's above. This is getting into talking about skewed data and things like that, where the mean goes, but your mean is always your balancing point of the distribution. We talked about the median.
Would that actually work if we did that with the pennies?
Yeah, I think so. Okay, what I want us to do now, everyone look really quickly before you keep entering data because everyone's looking at their calculator. Just look up really quickly. If you scroll down, the median is right here. Med. So it gives you the mean and the median. You're going to type in one set of data. You can either overwrite it by just typing on top of it. So if I go back to stat, edit, I can either type on top of it,
do
or
that.
like let's say that you have more data points in this list than the next one. If you go up to L1, so where L1 is highlighted, everyone do that now. I want you to hit clear and then down. That's going to get rid of it. Do not, everyone look at me, this is so important. Do not hit delete when you're highlighting the list. Don't hit delete. Your calculator will just blow up and die. So don't hit delete. Don't delete a list. Don't delete a list. You clear it.
My thing's like scratching.
It goes away. So don't delete it.
I did not
Clear the
realize
list.
that My calculator's still here.
That's my calculator from high school, so you please treat it carefully.
I definitely.
So the original set of data had a mean of 6 and then a median of 5.5, right? So, and then that data was,
What you talking about? 6.5. 6.5. Tina.
oh, 6.5. I didn't know. I just,
She didn't get your job. See, I got the information.
it was, the median was 6.5?
They're both 6.5.
Okay. Oh, they're both 6.5. Okay, so the original and the shape of it was what?
Approximately.
It was symmetrical.
Yeah.
So what do you notice about the mean and the median with these?
The median.
They're the same.
Same because they're
Oh my gosh.
symmetrical.
So when the median and the mean are the same, they make a symmetrical shape. I know, crazy. So then, after that, whoops, skip. After that, they changed the 10, which was the biggest point, to 15. So when you did that, what happened?
Mean rose, but median remained the same.
Median stayed the same. This is a different set of data.
Yeah, that's not the same.
What's that?
It is. So I'm gonna just write it down. So when you change, stop. So when you change the 10 to a 15, created more of an outlier. The mean was what? 6.75, but the median did what? 6.5. So what did you notice about the changes in the mean and the median? Median stayed the same, but the mean gets greater. So the mean is pulling towards the outlier. So the mean pulls toward the outlier. The median stayed the same because the middle values did not change. When I changed that 15 to 20, what happened?
The mean got even more big.
What did the... That was so profound. What did the mean change to?
7.
And the median stayed at 6.5. So the mean got even bigger,
Got even more big.
got even more big. The mean again pulls towards the outlier.
Now it's bigly. Got bigger.
So statistics are not affected by extreme values are said to be resistant. This is a new word, so circle it on your PowerPoint. Resistant.
Where's this?
It's like the second page of slides.
Bet.
Third page.
So when your data, or when your statistics, so including mean and median, when they're not affected by outliers, and outliers meaning I changed the 10 to 20, or I changed the 10 to 15. I changed that and made it an outlier. Was the median affected? No. So would that be resistant? Yes.
What if the middle value has changed?
If you're adding or subtracting more values, that's not the same thing as being resistant. It means you're changing one value, keeping the same number of values, but changing one value to be an outlier. Then that would not affect the median. Is the mean resistant? No.
No, it's not.
Because the mean is affected by outliers. So, first set of data looked like this. We said it was symmetrical because the mean and the median are the same. Then you took a second set of data it should have looked like a right skew. What do you notice about comparing the mean and the median now? The mean is greater than the median. So the mean is always going to pull towards the tail. So in a right skew, mean is greater than median. In a right skew, because the mean always pulls towards the tail. So then on the third set of data, you had a left skew, so then the mean is going to be what? Less than the median. So in a left skew, mean is less than median because the mean pulls towards the tail, which is the lower side of values. So in recap, in a symmetrical distribution, the mean and median are equal. In a skewed distribution, the mean is pulled in the direction of the skew. When you're cussing, my philosophy is always use the median when cussing because it's resistant. But you could use the mean in a symmetrical distribution. But for sure in a skewed, you need to report the median because it's more accurate measure of center.
So we're doing mean now when we have skewed?
You can use the mean when you cuss now.
Yeah.
But I would still say use the median because it never hurts to use the median.
I'm doing both.
Now, on free responses, a lot of times it'll ask the question, like, why should you use the median instead of the mean? It's because of this right here. Because the median is resistant to outliers. That concept comes up every year on a free response. Knowing the concept of median is resistant to outliers. That's why you report it as a measure of center.
So is mean a measure of center?
Yes, it is. We just usually, when we cuss, we say the median. The last thing is what we call a trimmed mean. A trimmed mean, the purpose of it is to remove outliers. So maybe when I am wanting to calculate the average test grade, somebody really bombed the test and I just don't want them included in my mean. It doesn't really seem fair to do that, but when you calculate a trimmed mean, you have to take from the bottom and from the top. So that's what makes it okay to do. So let's get some practice calculating the mean of this data. So everyone go to Stat Edit, put this in your list 1.
Bro, turn that kid.
Stat. Clear down arrow. Oh, what just happened?
Turn that kid.
Okay, so I'm putting all the night in there.
So it's a right skew because the mean is greater than the median. Now we want to find a trimmed mean. So let's say I want to find a 10% trimmed mean. How many data points do I have? 10? I have 10, so I'm going to take off 10% from each side. I'm going to remove one observation from each side. So when you have a 10% trimmed mean, I'm actually taking off 20%. So you're taking away 20%, technically, because I'm taking 10% from the bottom and 10% from the top. This is something that everyone misses on a test.
Will not.
If you miss this, you are killing a puppy.
Aren't you taking?
No, not again.
Yes.
Aren't you taking 10% from the whole thing, which is 5%?
Nope. You don't take 5% from each side. You take 10% from each. So if you're doing a 10% trimmed mean, you take 10% from each side.
So, just like you're asking, you want something.
Don't kill a puppy.
Yeah.
best number.
Bro,
That,
yeet
I
that
can't
puppy out
deal
of
with that,
existence.
the picture of the pod.
I know. It sucks.
Oh
Just
my.
never say anything negative.
So take those away and find a new mean.
What's it means?
What is the mean?
Left.
What's the mean?
22.
22?
You did it wrong.
Do you want us to go ahead and calculate it?
Yeah, so the new mean should be 22.
Sounds good.
Are we okay with that?
Yes, ma'am.
Yes.
Alrighty.